Hi dear students, welcome to this video. Today we discuss about preparation of carboxylic acids, various methods of preparation. We can prepare carboxylic acid from nitrile or Grignard reagent and even more starting materials. These two methods are to be discussed in detail because they are explicitly mentioned in the syllabus. These methods come in other modules also. Starting with the first one, from nitrile or cyanide we can prepare carboxylic acid very easily by simple hydrolysis. So RCN, nitrile or cyanide on hydrolysis. Hydrolysis means split with water. It can be in presence of acid or base. That is acid hydrolysis or acid catalyzed hydrolysis or basic hydrolysis. In both cases you get the carboxylic as the main product and there is a byproduct, that's ammonia. Whenever nitrile is hydrolyzed, you will get smell of ammonia. What is the difference here? In acid hydrolysis, you get carboxylic acid in the free form, and ammonia, that is a base, will appear as a salt. Whereas in basic hydrolysis, in presence of base, the base ammonia remain free and acid will become its salt. So this is a general rule, or it's an important generalization which you can find in organic chemistry. If a reaction is taking place in acidic condition, acid will be free and base will remain as salt. In basic condition, base will be free and acid will appear as the salt or its carboxylate ion. Now, these are two examples. Before these examples, see, whenever you learn organic reactions, the best way to understand the reaction is by looking into its mechanism, even if it is not mentioned in the syllabus. Wherever you see an organic reaction, look into the mechanism, because mechanism is the story of the reaction. It explains how the reaction has taken place. It is the sequential account of the various steps of the reaction. We will discuss mechanisms in detail at places where it is specifically mentioned. However, this reaction can be simply understood in this way. That is, see here, this cyanide or nitrile, there is a triple bond between carbon. We are adding water molecule. So first of all, we add two water molecules breaking two bonds. So this bond is broken, H and OH is added. One more bond is broken, H and OH is added. So what you get? One bond is intact. So it becomes now RC is now having two OH groups, single bond NH2. This is known as geminal diol. Two OH on the same carbon, very unstable, that will lose water, and it will now become RC double bond ONH2. What is this compound? This is called amide. So see that this hydrolysis of nitrile takes place via this intermediate. So that's to be noted. This hydrolysis is taking place through this amide formation. So this is the partial hydrolysis, and after complete hydrolysis it forms the acid. So what happens now? Now this bond is again broken by another molecule of water, H and OH, right? This is also broken. So what do you get now? You get RCOH acid and NH3, that's ammonia. Based on the condition, one will be free and the other will remain as the conjugate counterpart. Okay. Now coming to examples. What is the product here? In this reaction, this is what? 1, 2, 3, 4. 4 carbons. So butane nitrile. That is the IUPAC's name. It is also commonly called, based on the name of the corresponding carboxylic acid, that is 4 carbon acid is butanoic acid. So butanonitrile. Okay, so it is butane nitrile. On hydrolysis, it's simple. Cn is changed by COH. That's all. CH3, CH2, CH2, COH. Of course, there is byproduct, that's ammonia. In organic reactions, one is interested in the main product. You can avoid writing byproduct, doesn't matter. In the next reaction, this is benzonitrile because it is coming from benzoic acid. The corresponding acid is benzoic acid. So what do you get? You get the corresponding acid, that is COOH, that is benzoic acid plus ammonia. Okay? So that is hydrolysis. One point is here. This is acid hydrolysis, so acid will be free and it will be plus NH4 plus if I write the byproduct. In this case, it is a base hydrolysis, so what? This will be the salt. If it is NaOH, it will be sodium salt, that's all. We can write as the benzoate ion plus NH3 will be free. Okay? Now this method is known as nitrile synthesis, right? Because the starting compound is nitrile, this is called nitrile synthesis. Now importance of these two methods is that this can be used to step up the series or ascend the series. That means you can introduce a carbon into the chain and prepare a higher acid. That is, see, cyanide or nitrile is generally produced from what? From which compound this is generally produced? From RX, that is alkyl halide. You might have learned this in alkyl halides, nucleophilic substitution reactions in your +2 course, right? SN1, SN2 mechanism. Alkyl halides undergo various substitution reactions. X can be replaced by Cn. Okay, so by nitrile synthesis, when you are introducing Cn, you are adding a carbon, isn't it? So this carbon is added to this alkyl group, so you can step up the series. You can prepare an acid with 1 carbon more than the original alkyl group. And again, where is this alkyl halide prepared from generally? Alkyl halides are prepared generally from what? Anyone? You remember? It is from alcohol. Okay, so generally alcohol is the starting point, which can be converted into alkyl halide, which can be converted into various compounds, here nitrile, and on hydrolysis give acid. Okay, so that's the advantage of this nitrile synthesis, stepping up series. The same feature is valid for this, the second method also, preparing acid from carboxylic acid from Grignard reagent. So this method is also called Grignard method, Grignard synthesis, right? Now what is the reaction here? You know that RMgX, alkyl magnesium halide, it can be also aryl magnesium halide. See, it can be as well aryl group, right? Equally reactive. How this is prepared? You know that. This RMgX is prepared from alkyl halide again, treating with magnesium in dry ether. The solvent is very particular in Grignard synthesis, dry ether, because magnesium is quite reactive and you cannot have any aqueous medium, so dry ether is used. So this give you RMgX. It's an organometallic compound, very useful reagent for various synthesis. Okay, now what? Treated with CO2. You might have learned about use of Grignard reagent for preparing various types of alcohols in the other module, preparation of alcohols, starting from aldehyde and ketone. There you have carbonyl group, C double bond O group, and the reaction takes place. In CO2 also, you know, there is carbonyl group, isn't it? CO2 is this one, correct? C double bond O. This oxygen is highly electronegative and pi bond is loosely held, so it will shift towards oxygen, developing positive charge on carbon. So it is a nucleophilic center. I mean, a nucleophile can attack this carbon. So that is the reaction. It's a nucleophilic attack only. So with CO2, this happens, reaction takes place. So this R will attack this carbon and CO2 comes in the middle of these two. In between R and Mg comes CO2. So you have RCOOMgX plus and minus. The reactivity of RMgX, you might remember that magnesium is highly electropositive, so it is losing electron, developing positive polarity here, and R is getting negative polarity. So R is becoming a kind of nucleophile here, so it can attack a nucleophilic carbon. Now the second step is acid hydrolysis. This is just broken by water. Okay, so H here and OH here, this is hydrolyzed, you get the product carboxylic acid, right? And MgOHX as the byproduct. Okay, now two examples given here. CH3CH2Br. See, this alkyl group, you know, this Br, there is a correction here. This is not just CH2CH2Br. There is it's a Grignard reagent, so Mg has to be there. Okay, so this alkyl group is attacking this carbon, right? And it forms this intermediate CH3CH2COONGBr hydrolyzed to get this propanoic acid. The next one, this is phenyl magnesium bromide plus CO2 in presence of ether, giving this intermediate. This is plus and minus, and hydrolyzed to get benzoic acid and byproduct. So both of these reactions, the nitrile synthesis by hydrolysis and Grignard reagent or Grignard synthesis starting from Grignard reagent, the reaction is known as carboxylation. Why? Because you are introducing CO2 into this. So it's carboxylation. Carboxyl group is introduced. That's why the name. This is also known as carbonation. Carbonation. Right? So these two synthesis, these two methods are synthetically very important because it provides synthetic route for preparing higher acids or ascending series. We can see a question down here. Try to do this. Convert bromoethane to propanoic acid. How you do it? How can you do it? How you design or plan a synthesis? Yes. Whenever you have a question for conversion, first what you do is you write the starting compound and the final compound. So it is bromoethane, CH3CH2Br, okay, to be converted into what? Propanoic acid, CH3CH2COH. So looking at these two, you can make an intelligent guess. This is ethyl group 2 carbon and here there are 3 carbon. So you understand that one carbon is to be added. You can add carbon in two ways. In nitrile method, you are adding carbon through CN. In Grignard method, you are adding carbon through CO2, isn't it? You can follow any method. If we are following nitrile synthesis, first you will treat it with KCN. That's a reagent for substituting Br by Cn. So you get what? CH3CH2Cn. And then you just go for hydrolysis. H2, if you can go for acid hydrolysis, for example, and getting the product plus byproduct, that is NH4 plus. So that is the conversion, right? Okay. Now Finally, other methods of preparation of carboxylic acid. We will quickly go through this with one example. As I said earlier, these reactions occur in other modules. You might have sometimes learned in your 4th semester also. From alkene you can prepare carboxylic acid, that comes in 4th sem. From alkene, what is the reaction? How you convert? If you remember, let me take an example. This is butene. This can be converted into carboxylic acid by what is known as oxidative cleavage. Breaking this pi bond, it's an oxidation, or it is called oxidative cleavage. What is the reagent used? This you learn in properties of alkenes, right? When you learn hydrocarbons. So what you do is you go for drastic oxidation using alkaline KMnO4. You know that alkaline KMnO4 is a very powerful oxidizing agent. What happens? This is broken and each end carbon become acid. So the product is now CH3COOH, that is acetic acid or ethanoic acid. See, this is a symmetrical alkene, so you get 2 molecules of acetic acid. This is oxidative cleavage. One point to be noted here is, when there is a hydrogen here, then you get carboxylic acid. That is a requirement. Okay. If not, it will be a ketone. For example, if the compound is like this, CH3 double bond like this. This one, if you go for oxidation, oxidative cleavage, this will break here and it would become generally a ketone. That means it will be acetone, CH3CO like this. Okay, generally. If you go for very severe conditions, it may break and get oxidized into carboxylic acid. Now the next one, from alcohol and aldehyde. This is very important in organic chemistry. Converting alcohol and aldehyde, interconversions, and carboxylic acid. See, if I take primary alcohol, RCH2OH is oxidized. For oxidation, we can use, as I said, either alkaline KMnO4, that is one option, or acidified potassium dichromate. These are 2 very common oxidizing agents used in organic chemistry. So primary alcohol on oxidation, first it becomes aldehyde. On further oxidation, it becomes carboxylic acid, right? This is an important conversion in organic chemistry, an important sequence utilized in conversions. Now this in the reverse direction, carboxylic acid on reduction. For reduction we use lithium aluminum hydride, sodium borohydride, etc. This becomes aldehyde, which on further reductions give you primary alcohol. So this is primary alcohol. Okay. So primary alcohol on oxidation will end up with carboxylic acid. If you want to stop at this stage, there are some special oxidizing agents like PCC, etc. Pyridinium chlorochromate for stopping at aldehyde stage. This aldehyde is prone to oxidation, easily oxidizable into acids. So you need some special oxidizing agents. Now this reaction can be understood in this way. How this happens? What is happening here? See, primary alcohol can be written like this. As I said earlier, whenever you see an organic reaction, you should look into it, how the reaction has taken place, so that you understand the reaction. So you know that oxidation is addition of oxygen or removal of hydrogen. So when you are adding oxygen, what happens is that water is removed. Oxygen is removed in the form of water. So it becomes what now? RCOH. So this is aldehyde. On further oxidation, what happens? It is simply adding an oxygen here and this H become OH. That's all. It's becoming acid. Now, the reverse, acid is reduced into aldehyde. What happens? When you add, reduction means addition of hydrogen. So first of all, you are adding hydrogen here. So this is broken. So what it becomes? It becomes now RCOH. There are two OHs. Okay, one H is here. As I said earlier, this is a geminal diol, very unstable. Water is removed. It becomes aldehyde. And this aldehyde, on further reduction becoming primary alcohol, can be understood like this. That is, you are adding again hydrogen. That is reduction. You are adding hydrogen. So that is added here. This pi bond is broken. What is it now? RCH2O is the primary alcohol. Okay. Now, if it is a secondary alcohol, what about the oxidation? If you are using secondary alcohol, for example, there are two R group, CHOH. This on oxidation using alkaline KMnO4, what happens is that if you are adding oxygen, that will take away water like this, and it becomes what? It becomes ketone, right? It will give ketone only. If you are going further for drastic condition, refluxing for long time at high temperature, this may break, as I said earlier, and give you carboxylic acids. Otherwise, it will be ketone only. Okay, so that is the second method. Now, in this one, so these reactions you learn in the chemistry, the properties of alcohol and aldehyde. The last one, from alkyl benzene you can prepare carboxylic acid. From alkyl benzene, this you learned in 4th semester in aromatic hydrocarbon. See, let me take an example. If you have an alkyl group here of any length, suppose it is methyl or ethyl or any long, this can be oxidized using again alkaline KMnO4, that's the oxidizing agent. The side chain is oxidized fully into carboxylic acid. This is known as side chain oxidation. Okay, side chain oxidation. If it is ethyl group, that also will be giving you carboxylic acid only. So what is the point? Whatever is the length of this alkyl group, every other carbon will be burned into CO2 and H2O, and leaving one carbon with the ring, that will be intact and it become acid. So that is the point. And another thing is, suppose you have the substituent here, that is tertiary butyl group is here like this. Okay, tertiary butyl group. This will resist oxidation. Can you say why? So this side chain oxidation require at least one hydrogen with this benzylic position, this carbon. There is no hydrogen here, so that is not easily oxidized. But if it is an isopropyl group, this is called cumene, right? You know cumene. This get oxidized and it will give benzoic acid, right? Because there is one hydrogen. So these are various methods of preparation of carboxylic acid. So practice all this, right? We will do more questions in the live session. Thank you.